Welcome to Science Lesson 6.3. Today we're going to be talking about elements. Specifically, we're going to be talking about elements as well as elements versus compounds. So what is elements versus a compound? Well, to start with, let's talk about the definition of an element. An element is a substance that is composed of only one type of atom. So if you see in the orange picture down there at the bottom, you see oxygen atoms. So the element of oxygen, you can see it's just that one red ball. It's one type of atom. Remember, we've discussed that an atom is the smallest piece of something that can still be that particular type of thing without changing. If you cut any part of it, it becomes a different piece of something. So an element is a substance that is composed of only one type of atom, so only one of those smallest particles of matter. That's an element. Well, a compound is a substance that is composed of more than one type of atom bonded together. So, for example, in the blue picture, you see H2O compounds, which, by the way, that would be the chemical makeup of water. So you have hydrogen, two hydrogens, and one oxygen. So it's a compound because you have more than one type of atom and it's bonded together, meaning it's attached. So you have a compound, more than one type of atom that's attached together. Some things around your house, most things around your house, I should say, are made up of compounds, but there are some things around your house that are made up of pure atoms, just pure elements, I should say. Not pure atoms, everything's made up of atoms, but pure elements. Do you know, do you know what those things might be? Well, think about it. Aluminum foil. It's made out of aluminum. Aluminum is an element. So it's not bonded with anything. So it's a pure element, not a compound. If you have something that's made out of iron, that's also a pure element, not a compound. So some things that you have are elements, but probably a majority of things that you have, those are compounds when you take elements and you join them together. Well, now let's keep talking about atoms with their atomic names and numbers. We already started talking about atomic numbers in our last lesson. So elements have been identified for years by scientists. There's over 100, about 118 right now, that have excuse me, been identified by scientists. That's a lot of different elements. So they range from the little teeny tiny hydrogen atom, which has only one proton, to octium, which has 118 protons. So there is a lot of elements out there. The atomic number, remember, that is the number of protons in an atom. So the atomic number of an element is equal to the number of protons. If you know the number of protons, you know the atomic number. If you know the atomic number, you know the number of protons. Each element has its own atomic number, and this is because each element is composed of a unique type of atom. So each atom has its own number of protons. It doesn't change. Protons. If you change the number of protons, you change the atom, so you change the element. So the atomic number identifies the element because only that element will have that atomic number. If you take away even one proton, you change elements. So the atomic number determines the type of atom. If you change it, you change that particular, if you change the atomic number, you change that atom. There's a lot of information that we have to learn about atomic names and numbers and how they work. So each of the 118 known elements has a symbol as well as a name. So we've already talked about atoms like hydrogen atoms, oxygen atoms. So each of those have the name hydrogen, oxygen, so on, but they also have a symbol because every time you're talking about a particular type of atom, you don't want to write out hydrogen, you don't want to write out oxygen, you don't want to write out octium. You're going to want to write out something faster. So everything has a symbol. Sometimes it's the first letter. For example, we use H for hydrogen, O for oxygen, N for nitrogen. Sometimes it's the first letter and another prominent letter that helps identify it. For example, Cl for chlorine. We have Si for silicon, Al for aluminum. So those help to identify it. Sometimes it's based on the Latin name. For example, Fe for iron because its Latin name is ferrum. So it just kind of depends on what's already been used. For example, IO has already been used, so that's why we couldn't use IO for iron. You had to use or I has already been used, excuse me, not IO. I has already been used, so we use Fe for iron. Most of the first 92 elements, so these would be elements with 1 to 92 protons, occur naturally. So that means they're already in nature, just the way God made them. The exceptions are technetium and promethium. Technetium, that has the atomic number of 43, so 43 protons, and promethium has the atomic number 61. So technetium, 43, promethium, 61. These elements are man-made, so they have to be created by man. They don't naturally occur. You wouldn't find them except under very, very rare circumstances would you see them. Then also all of the elements that have greater than 92, an atomic number greater than 92, they are also man-made elements. Uranium has the highest atomic number of naturally occurring elements. So it has an atomic number of 92. So uranium has the highest number. Elements past uranium are called transuranium elements, the most abundant of which is plutonium. That means that they're of all the elements that are transuranium, so they have a higher atomic number than 92. They're all transuranium. The one that has the most particles that exist in this earth would be plutonium. That's a very radioactive, very dangerous substance, and its atomic number is 94. So the only way that we have these particular elements, they've been produced by scientists in a lab and are used for various things. Usually, the higher the atomic number, the denser the element. Because think about it, you're adding protons. When the atomic number goes up, that means you're adding protons. So you're adding more material, so it's getting denser. The densest element that we know of is osmium, which has the atomic number of 76. It's a metal, very similar to platinum. All right, if you take a look when you do your reading at table 6.3a, that shows elements that make up the Earth's crust, oceans, and atmosphere. So you can see the kind of elements that are common, that are very naturally found here. You also have table 6.2 with the selected elements and their symbols, so you can take a look at that and kind of be familiar with that before we dive a little deeper into elements with the periodic table. On page 291, you have table 6.3b. That shows elements that your body is made of. And then table 6.3c shows elements in the universe, so things that are in the air. All right, that is it for our lesson part. For your homework, you need to read through pages 288 through 291. I've covered a lot of it here, but there are some extra details in your reading that you need to make sure you look over. If you have any questions about what you're reading, just let me know. Then you need to complete comprehension check 6.3, page 291, and study for your science quiz that you will take on Thursday. That's it for today. Have a wonderful day, guys. Love you very much. Bye.